Hey Chemsters, this is Mrs. Vandaloy bringing you another Chemster video, still from Chapter 7. Now this time we are talking about covalent nomenclature. And if you remember how we started this whole unit out, we looked at the differences between ionic and covalent. And what do ionics have in common? They all have ions, correct? And most of your ions start with a metal. So metal, non-metal. What was our one exception was ammonium. You just have to know that one. So how did we recognize a covalent compound? That is when we had a non-metal with a non-metal. And probably the most common one that comes to my mind is carbon dioxide. Carbon's a non-metal, oxygen's a non-metal, all right? There are no ions, okay? So there's no charges to memorize, okay? And we will talk about these kind of compounds after we're done with the nomenclature unit. And these covalent molecules are bonded together by sharing electrons, not by charges. There is absolutely no crisscrossing. Why not? There are no ions to crisscross, okay? So to me, this is simple dimple, okay? The covalent is really all, what's written is what you see, okay? So to write the formula, the prefix in the name of a binary molecular compound, I'm not talking about sugar, which is like, C12H22O11. That's not binary, that's poly, okay? You have three different atoms there. But the prefix in the name of a binary, two atoms, molecular compound. Molecular means non-metal, non-metal. Let's put that down. So a prefix in name of a binary, which means two. Molecular means non-metal, non-metal. Compound tells you how many atoms of an element are present. If there is no prefix on the first element only, did you catch that out? Only, then there is no subscript. So only one of the first element is present, okay? There will always be a prefix on the second element indicating the subscript, okay? So what are these prefixes? Let me scroll this chart up and we'll find out. So we use the prefixes that are of Greek origin, all right? You may or may not be aware of, there is, let's say, more than one way to say for something, like a quadratic or a quadrilateral. That would be one way to say four. Quadrants, there are four quadrants, okay? That would be the Latin root. We are using all Greek roots, which are a little bit different from the Latin. So let's say one in Latin is like uno, but in Greek it would be mono, okay? So we use that. Probably your di and tri are not too difficult for you. What's four? Four is that tetra. So when computers first came out, you probably don't remember that, Tetris was one of my favorite games. And how many blocks are in every Tetris shape? There's always four blocks, if you notice that. All right, so the rest of them should look pretty familiar. Like how many sides is a five-sided figure? We call that a what? A pentagon. Then a six-sided figure we call hexagon. And a seven-sided figure we call a heptagon. Folks, this is where we get our month of September. It came from this prefix hept. October, November, December. So these are where our last 4 months come from. But Mrs. Vandaloy, I thought September was the 9th month, and October is the 10th month, and November is the 11th month, and December was the 12th month. Why are they always off by 2? Because in the calendar, Julius and Augustus needed their months squeezed in, forcing those last 4 to be off. Okay, I hate to tell you that. So anyway, but that's where the original hept, oct, non, and dex still means 7, 8, 9, 10. Okay. Now, what else did I put here in letter D? Every single one of these binary. So if it's binary ionic, it ends in "ide." If it's binary covalent, it ends in "ide." All right. So let's see how these work. Well, I sure hope you know how to do CO2. That's probably the most common one you have. And so how do I name it? Does it follow the rules? It is carbon dioxide. Why is it not monocarbon dioxide? Because I have one carbon. Let's scroll back up here again. What does it say? If there is no prefix on the first element, there is no subscript. So is there a subscript on the first element? No, there is not. So there is no prefix, okay? How about number 2? Okay, what do I do with this one? There's no prefix, or there's no subscript, there's no prefix. The second one must have a prefix. That's what it says here. There will always be a prefix on the second element indicating the prefix. So if the prefix, or excuse me, the subscript is 1, then it's carbon monoxide. And you probably have heard of that. There's carbon monoxide detectors out there so you don't get poisoned in your sleep. Okay, so about number 3. Hey, I see a subscript here. It's a 2. Well, what's the prefix for 2? It is di. So it's diphosphorus. And what's the prefix for 10? Dec, or in this case, decahydride. Okay, so diphosphorus decahydride. It just sounds better if you stick that little in it. All right. Well, the next one. Hey, I see a subscript. Okay, so what does that 2 tell me? I need a prefix. So what's my prefix? What's the prefix for 2? It is di. So it's dinitrogen pentoxide. What's the next one? Hey, do you see a subscript? I don't. So what does that mean? It's just plain old sulfur. Sulfur what? 4 tetrafluoride. Hey, how do you spell fluoride? F-L-U-O-R-I-D-E. Remember that? So number 6, finally, what is Se? Oh, that's selenium. Do you remember that? Do you see a subscript here? I don't. So do you need to put down a mono? No. All right, so it's just selenium. And how do you say 6? Up here, hex. So selenium hexachloride. Come here. It's not moving. There it is. So selenium hexachloride. Once again, it sounds better to put the after the hex, so it's not hex chloride, make it hexachloride. It just sounds better. All right, let's see what the next one is. Hey, we're going to do the opposite, so hang on. All right, so this is where you use the prefix and the name to tell you the subscript of each element in the formulas. Again, if there is no subscript, there is no prefix. If there is no prefix, there is no subscript, okay? So in example number 1, carbon tetrabromide, do you see a prefix by the carbon? No, you don't. What does that tell you? You only got one of them. What's tetra? 4. So this would be CBr4. Please make a note of this. There is no crisscrossing. As I have taught this for many, many, many years, the students that are not paying attention will write C4BR1 because they kind of crisscross the prefixes. Don't do that. You write down what you see. So I don't see any prefix with carbon, so I have 1 carbon. I see a prefix with bromine, I have 4 bromines, okay? So these go together if they're written together, okay? So what about the next one, diphosphorus trioxide? What do you think it is? Go ahead and write it down, see if you're right. All right, this is what I got, P2O3. That was pretty easy, wasn't it? How about the next one? Go ahead and do that one. Well, I got PCl5. Great. How about the next one? Did you get IF3? I did. Iodine trifluoride. 1 iodine, 3 fluorines. How about the last one? Want to do this one? No. Get it? All right. So anyway, nitrogen monoxide is NO. So anyway, that is all there is to covalent. Again, we're going to be practicing these tomorrow. So I'm just going to leave you with this. Don't wait to be great. See you tomorrow. Bye-bye.